Hello. I want to talk about the solution to problem 10 in sample midterm 2, which is also a lot like your problem 2 on the web work due next Monday, web work set 15. This is Airy's equation, y double prime plus xy equals 0. It's called Airy's equation. It's actually an important equation in the history of physics. It's used in optics and in quantum mechanics. All right. So one of the things that's interesting about it is when x is positive, I get oscillatory solutions. It's sort of like y double prime plus y equals 0, sines and cosines. And when x is negative, I get decaying or growing exponential type solutions, a little bit like Cauchy and Sinh. All right. I've also put in the answer here in case you want to just try it on your own and see if you can get the answer. Okay. So let's jump in and plug this y function in. Y prime is sum from n is 1 to infinity n cn x to the n minus 1. And y double prime is sum from n equals 2 to infinity n times n minus 1 cn x to the n minus 2. All right. Plug that in here, and you get sum from n is 2 to infinity n times n minus 1 cn x to the n minus 2 plus x times sum from n is 0 to infinity cn x to the n. That's all going to be 0, which I remind you is 0 plus 0 times x plus 0 times x squared plus 0 times x cubed plus dot dot dot. The 0 function on the right. Okay. So this term is going to be here plus sum from n is 0 to infinity cn x to the n plus 1 when I bring the x in. In this one, we're going to do that trick we've done a few times, and you notice that in the scanned solutions that you can also look at, I've done this once and for all and go right away and write an equivalent form for y double prime. This result of this, you let m be n minus 2, so n is m plus 2, and then the limits are n equals 2. That corresponds to m equals 0. So this is sum from m equals 0 to infinity m plus 2, m plus 1, c m plus 2, x to the n. Okay? Now here, we want to do the same trick. We want this to be just x to a power. So let's let m in this case be the n plus 1, so that's x to the m. And then n is m minus 1, and n equals 0 corresponds to m equals 1. Okay? So now I'm going to rewrite the differential equation here. That one we've already got, and then we have to rewrite that one. So we have sum from m equals 0 to infinity m plus 2, m plus 1, c sub m plus 2 x to the m plus sum from m equals 1 to infinity c sub m minus 1 x to the m, and that's 0. Okay? All right. So I can't combine these as they are because this starts at m equals 1, this starts at m equals 0. But I can rewrite this. This is 0 plus 2 times 0 plus 1 c sub 2 times x to the 0 plus sum from m equals 1 to infinity And I'm actually going to end up combining terms, because now it's sum from m equals 1 to infinity of that, plus m equals 1 to infinity of that. I can put them all together and factor out the x to the m. So I get m plus 2, m plus 1, c sub m plus 2, plus c sub m minus 1. And that function is the 0 function. Well, this is just a fancy way of saying okay, this is a fancy way of saying 2c2. So this thing here, this equals 0 for m equals 1, 2, 3, etc. Okay. All right. So let's just do that. Remember, that's got to be 0. So what they combined give is that c2 is 0, the constant term, and m plus 2, m plus 1, c sub m plus 2 plus c sub m minus 1 equals 0 for these m's. So I can just solve that, and I get c2 equals 0, and cm plus 2 is minus cm minus 1 all over m plus 2, m plus 1 for m equals 1, 2, 3, 4, dot, dot, dot. Okay. There's recurrence relation. There's perfectly good recurrence relation. Doesn't look exactly like that, because here we have an m, but here we have n, but the content is exactly the same. You might remember way back in the very first video, I actually started with power series with m's in it, so I got the recurrence relationship with n's in it, but it doesn't matter. This is perfectly good. These are both correct answers. I would give them both full credit on the test. However, if you leave that out, you don't get full credit. If you leave that out, you don't get full credit. That whole thing is a recurrence relation. Okay? Anything else to say about it? Yeah, one more thing. What happens if I try to plug in m equals 0 in this equation? I would get c2. Oh, that's good. I get an equation for c2, it looks like, but c2 would be negative c sub minus 1. C sub minus 1 isn't defined. C sub 0 is the smallest subscript of c. 0 is the smallest subscript of cn. So, right, this equation doesn't work when m equals 0. Gotta put that one in separately. Okay, so stay well, and send me email or text me, whatever, with any questions you've got. Okay, bye.